Most days you probably just walk right past the landscaping at like a retail center or an office park,
Yeah.
or maybe a really big apartment complex.
Yeah, you don't even really see it.
Right. You don't give it a single conscious thought. I
Yeah.
mean, you park your car, you're checking your phone, and you walk past this vibrant patch of green grass right there by the sidewalk, and you just go about your day.
It's totally just background scenery to us at this point.
Exactly. We are completely conditioned to expect the built environment to just, feature these pleasant little pockets of nature. We assume someone is just doing a bit of gardening behind the scenes.
Yeah, we really treat it as a default setting because, well, our urban spaces are designed to mimic this temperate pastoral aesthetic.
Like a park in England or something.
Right, exactly. It
Yeah.
was essentially imported wholesale from those damp, rainy climates of Western Europe. And I mean, setting up a sprinkler and throwing down some fertilizer, that works fine in Ohio or London. But when you transplant that highly specific aesthetic into the middle of the Mojave Desert, maintaining that illusion stops being gardening entirely.
Yeah, when you look at a place like Henderson, Nevada, keeping that little patch of green alive it's a high-stakes, highly engineered, and honestly incredibly expensive war of attrition.
Oh, absolutely. It's a war against one of the most extreme climates in North America.
The desert desperately wants that grass dead, and fighting that reality has this massive, often completely hidden cost.
A cost that goes far, far beyond just a high water bill, too. I mean, it bleeds into municipal infrastructure, environmental policy, and obviously corporate bottom lines.
Okay, let's unpack this, because we are starting with a collection of really fascinating sources today. We are doing a deep dive into a series of detailed service insights and industry blog posts from Henderson Artificial Turf.
Yeah, these were written by a landscaping and engineering analyst, John Constantine, back around mid-2026.
Right. And our mission for this deep dive is to use these sources to basically uncover the surprising economics, the really intricate material science, and the intense geotechnical engineering that goes into commercial artificial turf.
Because it is intense.
It really is. I read through this stack of research, and spoiler alert here, replacing grass with synthetic turf in a commercial environment is staggeringly more complex than just rolling out a giant plastic rug.
Way more complex.
So I'm calling our first major takeaway from the sources the Mojave math.
I like that. The math truly is the driving force behind this entire industry out in southern Nevada.
Right.
Property managers and urban planners, they aren't simply making these aesthetic choices to switch away from live grass because they feel like it. They are being backed into a corner by some really severe economic and environmental pressures.
Yeah, water scarcity is basically the absolute defining factor for any physical business operating out there. The sources highlight that the Southern Nevada Water Authority has rolled out these incredibly strict mandates.
Very aggressive regulations.
Yeah, targeting what they categorize as, quote, non-functional grass.
Which is such a brilliant regulatory term, honestly. Non-functional grass.
It really is.
Because it strips away all the romanticism. I mean, it refers to turf that is purely decorative. No one is, playing a soccer match on it. No one's having a family picnic on it.
Right. It exists literally just to provide a visual pop of green next to a strip mall parking lot or like along a highway median.
Exactly. And in a desert region that's facing catastrophic long-term water shortages, dedicating millions of gallons of treated drinking water to non-functional grass has just become completely indefensible.
Indefensible on a civic level, yeah. The sources actually put some hard numbers to that water usage, and the data is honestly staggering.
It's a lot.
It's insane. To keep just 1,000 square feet of natural grass alive through a typical Henderson summer, you need 73,000 gallons of water annually.
Just let that number sink in.
73,000. I tried to visualize that, right? That is not just a little patch of damp dirt. That is a massive deep-end backyard swimming pool's worth of water.
Yeah.
Poured onto a patch of dirt roughly the size of a standard 3-car garage every single year, just to stop the blades from turning brown.
And keep in mind that 73,000-gallon figure is strictly the hydration requirement.
Oh, right. There's more.
Oh, yeah.
Yeah.
The true cost of natural grass includes the petroleum-based chemical fertilizers required to artificially enrich that sandy soil, plus the pesticides.
Right. Correct.
And then the continuous labor costs for weekly mowing and edging, the fuel for those mowers.
Yeah.
and the constant, inevitable repairs to those really complex irrigation systems that just degrade in the desert heat over time.
So looking at all those compounding expenses, maintaining natural grass in a commercial desert setting is literally like pouring 73,000 gallons of liquid cash directly into the sand.
Pretty much.
It is a fundamentally broken business model for anyone managing a commercial property.
Well, if we connect this to the bigger picture, you really start to see the true ROI, the return on investment of modern synthetic alternatives.
Yeah.
When a property manager replaces that living lawn with a commercial-grade artificial turf, the water usage doesn't just drop by like 20 or 30%. It drops to absolute zero.
Zero. And the local municipalities are so desperate to get that usage to zero that they actually offer substantial cash rebate programs to businesses that willingly make the switch.
Which effectively subsidizes the initial construction.
Right. Because, I mean, the upfront cost of excavating a property and installing premium commercial turf is undeniably steep.
Oh, we are talking about a major capital expenditure. It's not cheap to install. But because of those rebates, combined with the immediate elimination of that massive water penalty,
Right.
plus the labor, plus the chemicals, well, the math works out incredibly fast.
Yeah, the data indicates that the entire initial investment is typically recouped completely within just 3 to 5 years.
3 to 5 years is an incredible turnaround for infrastructure like that.
It really is. And once they hit that break-even point, all of those operational funds that were just bleeding into the dirt can be redirected. Property owners are taking that freed up capital and using it for core business functions or, upgrading their facilities.
Adding actual usable amenities for their tenants.
Exactly. The financial argument is absolutely bulletproof. But reading through the economics immediately made me, question the physics of it all.
How so?
Well, if the Mojave Desert routinely destroys natural living plants that have literally evolved to heal themselves, what exactly are these businesses buying that can survive out there?
That's a great point, and we really have to completely discard our outdated perceptions of fake grass here.
Yeah, it's not the AstroTurf.
No, we are not talking about that abrasive neon green plastic carpeting you'd find at a miniature golf course in the 1990s. Commercial-grade installations today utilize these highly advanced, really complex polymer chains. The material science is geared entirely towards surviving extreme ultraviolet radiation, high ambient temperatures, and heavy pedestrian foot traffic, all without degrading or losing tensile strength.
Yeah, the sources do this phenomenal side-by-side technical comparison of different landscaping materials that really puts this into perspective.
Yeah.
We know the baseline, right? Natural grass demands 73,000 gallons of water, constant seasonal seeding, and 4 to 6 hours of weekly maintenance.
Right.
But the real shocker for me was the data on the drought-tolerant desertscape option.
Yes. The default natural alternative.
Right. Swapping the lawn for decorative rocks, maybe some native cacti hardy desert shrubs. You would naturally assume that a desertscape in an actual desert would be the zero maintenance, zero water holy grail.
I don't think so.
But the data says otherwise. A 1,000 square foot drought tolerant desertscape still requires about 10,000 gallons of water a year.
Yep.
Plus seasonal pruning and weed management that comes out to about 1 to 2 hours of weekly labor.
And the reason for that is the urban heat island effect. It drastically alters the microclimate.
Wait, can you explain that? How does that bake the native plants?
Sure. So when you take native desert plants and isolate them in a commercial island, right, surrounded by acres of black asphalt parking lots and concrete buildings radiating heat,
Oh, it acts like a mirror.
basically,
Yeah.
you create an oven, the soil temperature just skyrockets, and the root systems can't spread out naturally to find deep subterranean moisture like they would in the wild.
Ah, so they're trapped.
Exactly. So even native plants require artificial life support in that engineered environment.
Wow. So when we compare that native struggle to the synthetic options, the engineering gap is just wild. A standard residential synthetic turf requires zero water, drops maintenance to less than an hour a week, and survives for about 8 to 10 years.
Which is solid.
It is. But the premium commercial turf, the heavily engineered product these retail centers are investing in, that has an expected lifespan of 15 to 20 years.
Which is crazy.
It boasts an exceptional durability rating, even under constant commercial foot traffic.
Yeah. Surviving 2 decades in the Nevada sun is a staggering feat of chemical engineering for any exposed synthetic material, really.
I bet.
The primary enemy out there isn't just the ambient heat, it's the ultraviolet radiation. UV rays essentially attack the molecular bonds of standard plastics.
Right, making them brittle.
Exactly. They become brittle, they fade in color, and eventually they just disintegrate into dust.
I actually found myself really pushing back on this while reading because I'm trying to visualize miles of plastic sitting out in August, baking in like 115-degree ambient
Oh
heat.
yeah, it sounds terrible on paper.
All right, you'd think the ground would just turn into a giant melting frying pan. Like a 20-year lifespan is great, but not if the material is literally burning the soles off your shoes.
And that is actually the most critical hurdle the industry faces, because synthetic polymers inherently absorb and retain thermal energy from direct sunlight. So the engineering response to mitigate that heat retention is this multi-layered system, starting with the infill.
And the infill, just to clarify for everyone, is that granulated material they brush down in between the individual blades of synthetic grass. It gives them structural support and keeps them standing upright.
Exactly. Now, older generations of turf, they used basic silica sand or recycled crumb rubber from old car tires.
Oh, I remember that rubber stuff.
Yeah, and crumb rubber is notorious for acting like a black body radiator. It absorbs the sun's heat all day long and aggressively radiates it back out, which makes the surface agonizingly hot.
Okay, so how do they fix that for commercial spaces?
Well, modern commercial installations just banish the rubber entirely. They use specialized cooling infills, often these coated ceramics or advanced acrylics, and they are specifically engineered to reflect infrared light rather than absorb it.
Oh, wow. And the fibers themselves are doing a lot of the heavy lifting too, right? Because the sources detail how the synthetic grass blades are manufactured with built-in UV stabilizer.
Yeah, they are highly specialized.
It actually made me think of fiber optic cables. The blades are shaped and coated to refract the sunlight, actively resisting the thermal absorption on a molecular level rather than just sitting there baking.
And some of the most advanced infills are even hydroabsorbent. They capture trace amounts of moisture from the morning dew or even just the atmosphere
Yeah.
and slowly release it throughout the day.
That's brilliant.
So when you combine that with strategic architectural shade sails or just a very light, quick rinsing with a maintenance hose on the absolute hottest afternoons, that evaporative cooling effect drops the surface temperature by dozens of degrees almost instantly.
Here's where it gets really interesting. Because you have this ultra-durable plastic surface that is fighting off the sun and retaining tiny bits of moisture to stay cool. But the Mojave doesn't just have heat.
Oh no.
When it rains, it doesn't drizzle. It unleashes these explosive torrential monsoon flash floods.
Right. And you'd intuitively assume that laying a massive sheet of synthetic material over the ground would act like a tarp, completely sealing off the soil.
Yeah, just creating immediate catastrophic flooding during a monsoon.
Exactly.
But the drainage capability of this turf is arguably its most insane technical spec.
It really is.
Professional commercial installations utilize this highly permeable backing matrix. It's essentially a heavy-duty mesh, and that backing is laid over a very specific, geotechnically engineered, porous subbase. The resulting system allows stormwater to drain through the turf at a rate of several hundred inches per hour.
Just let that metric sink in for a second.
Huh.
Several hundred inches per hour. It drains stormwater exponentially faster than native, uncompacted desert soil ever could.
So the surface basically functions like a giant high-tech sponge that immediately channels the water away. It completely eliminates standing puddles or mud.
It's remarkable.
The turf beats the sun, it swallows the monsoon floods, and it survives 20 years of foot traffic. But as the sources point out, none of this material science matters if the foundation it sits on is flawed. You can have the best synthetic fibers in the world, but if the earth underneath it shifts, the whole investment is just ruined.
Yeah, this transition from material science over to geotechnical engineering is where we have to definitively shatter a major marketing myth in the landscaping world.
Which one?
The illusion of the zero-maintenance synthetic lawn.
Oh, right. Because these products are relentlessly sold as install-it-and-forget-it solutions. But the Surface Insights explicitly warn that ignoring a commercial installation for a few years is basically a guaranteed way to destroy it. You are fighting the environmental reality of Henderson.
Right, because the desert is not a sterile vacuum. The wind out there constantly carries fine, abrasive desert dust, aggressive pollen, and organic debris from all the surrounding native brush.
Just constantly blowing in.
And every day, gravity and foot traffic grind that abrasive mix down into the synthetic fibers and the infill.
So over time, thousands of people walking over the surface, that compresses the synthetic blades downward, right? Which traps that dust. So the required maintenance protocol actually involves a physical process called cross-brushing.
Yeah, cross-brushing is essential.
Maintenance crews use these specialized mechanical sweepers to vigorously brush the fibers against their natural grain. This stands the blades back up, prevents permanent matting, and crucially, pulls that compacted cooling infill back to the surface so it can actually do its job reflecting the sun.
They also schedule routine, low-pressure power washing, to extract the really deep-set dust and clean up organic spills. Plus, for multifamily apartment complexes, pet waste is a huge, huge factor.
Thankfully, because of that matrix backing that drains hundreds of inches of water an hour, the pet issue is pretty much solved with a hose and some specialized enzymatic cleaners.
Right, the liquid just flushes straight through the system.
But there is one threat that you absolutely cannot wash away. The sources are incredibly strict about vehicle traffic.
Oh, absolutely. A single utility truck driving across a synthetic lawn can undo weeks of maintenance and permanently compromise the entire installation.
Yeah, the concentrated weight of a maintenance vehicle's tires will instantly crush those synthetic fibers beyond recovery. But more importantly, it destroys the carefully graded subbase underneath.
It ruins the foundation.
So if a contractor using like a scissor lift to change a light bulb absolutely has to cross a curve, the protocol demands laying down thick, weight-distributing protective boards. When I first read about how sensitive the subbase was to heavy weights, I realized my entire mental model of how this stuff is installed was totally wrong.
How so? What were you picturing?
Well, I had originally assumed the crew essentially just, cleared out the old grass, smoothed out the dirt, and rolled out a giant, heavy-duty grain carpet.
What's fascinating here is how catastrophic that exact carpet assumption is to the lifespan of the product.
Really?
Oh, yeah. Treating synthetic turf like an indoor rug is the #1 reason amateur installations fail within the first year. The native topography of Nevada just does not allow for shortcuts. Contractors are doing battle with something called caliche.
Right. The sources mention caliche soil repeatedly as the absolute ultimate nightmare for contractors. What exactly is happening there geologically?
So caliche is a shallow layer of soil where the dirt, the sand, and the gravel have all been chemically cemented together by naturally occurring calcium carbonate.
Wow.
It is essentially a layer of natural concrete hiding just beneath the surface of the desert. It is famously impenetrable, it expands unpredictably, and it has absolutely zero natural drainage.
So if a contractor just rolls an expensive, permeable synthetic turf over a barely scraped caliche base, the first monsoon rain will hit that natural concrete layer, pool up beneath the turf, and cause the ground to just heave and settle.
Exactly. The turf will severely buckle, the seams will rip apart, and you have a total structural failure on your hands.
So how do they beat it?
Yeah.
To defeat the caliche, the geotechnical preparation is intense, right? Excavation crews have to bring in heavy machinery to physically break up and remove tons of that cemented native soil.
Tons of it.
They dig down deep and replace the caliche with a heavily engineered, crushed aggregate rock base.
And they don't just dump the gravel in and rake it flat either. They use a technique called vibratory plate compaction.
Vibratory plate compaction, okay.
Yeah, they run these massive, vibrating steel plates over the aggregate. The high-frequency vibrations force all the jagged edges of the crushed rock to lock together, violently expelling all the trapped air pockets.
So they are literally vibrating loose gravel until it becomes a solid, unmoving foundation that is somehow still incredibly porous.
Exactly. It's like turning the earth into a dense sponge made of stone.
A sponge made of stone? That is so wild.
But creating that perfect stone sponge is only half the battle.
Yeah.
We also had to account for the physics of thermal stress.
Right.
Deserts are environments of extreme temperature swings. A surface might bake at 140 degrees in the direct afternoon sun and then rapidly cool down to 70 degrees at night.
So the material expands in the heat and aggressively shrinks in the cold. The entire lawn is literally breathing and shifting every single day.
Right. And the physical forces generated by a massive sheet of polymer expanding and contracting like that are immense. If a contractor uses standard landscape adhesives or just basic staples to connect the huge rolls of turf together, those seams will literally tear themselves apart within months.
Wow. So you'll just walk through a luxury retail center and see the synthetic grass bubbling up and separating into jagged strips.
Exactly. That thermal reality is why commercial installations mandate high-tensile, climate-specific chemical adhesives and advanced mechanical seaming techniques.
They aren't just gluing the grass together.
No, they are chemically welding the rolls into a single unified membrane that can stretch and contract as one piece without rupturing.
So you look at the sheer scale of this effort. You've excavated tons of natural concrete, you've vibrated crushed rock into a permeable sponge, you've chemically welded polymer sheets to withstand wild thermal swings, and you've committed to a strict cross-brushing maintenance schedule.
It's massive.
The upfront capital and engineering required is just massive. Which brings us to the ultimate question for the businesses actually cutting the checks. How do they monetize this highly engineered ground?
Right, what's the payoff?
Because they didn't just spend all this money merely to lower their water bill. This brings us to the specific commercial applications detailed in the sources, particularly what we'll call the corporate courtyard.
Yeah, the versatility of a climate-proof surface allows different sectors to drive totally different, highly specific business outcomes.
Right. For retail centers, sprawling office parks, and high-end multifamily housing complexes, the goal is really psychological. They are manufacturing an inviting, vibrant communal oasis in a visually harsh environment.
Yes, and a pristine green courtyard subconsciously boosts the perceived value of an apartment complex. It encourages tenant retention because, people inherently desire a connection to green spaces.
And for retail, that aesthetic magnet reliably attracts higher quality foot traffic to their storefronts.
It delivers all the proven psychological benefits of biophilic design, our innate human attraction to nature. But it entirely removes the environmental guilt of wasting water and the operational nightmare of maintaining a fragile ecosystem.
It's the best of both worlds. And corporate campuses are taking it a step further. They are using specialized turf installations like custom contoured putting greens or bocce-ball courts as direct recreational amenities.
Which is great for morale.
Yeah, it becomes an active tool for building corporate culture and retaining high-value employees who want outdoor breakout spaces. But my absolute favorite application from the Constantine sources is how the hospitality sector uses it.
Oh, hospitality is all about mitigating risk. Venues that host high-ticket outdoor events like weddings and corporate mixers, they rely on commercial turf because it guarantees an absolutely pristine, mud-free surface permanently.
Right. The predictability is the product they're selling. If you book a massive outdoor wedding and a sudden monsoon rolls through 2 hours before the ceremony, natural grass just becomes a swamp.
It's ruined.
You cannot have 100 guests in formal wear and high heels sinking into wet mud. But with the synthetic system, the water drains at hundreds of inches an hour, the surface dries rapidly, and the event proceeds flawlessly.
Yeah, in the event industry, removing weather-related liability from a venue's operational risk profile is just incredibly lucrative.
So what does this all mean? When you zoom out and look at the whole picture, from the SNWA water mandates to the vibratory plate compaction, how should you, the listener, apply this analytical framework to your own business decisions or even your own life?
Well, the story of commercial artificial turf is ultimately a masterclass in evaluating the total cost of ownership. We're looking at a classic pivot from a permanent liability to a predictable asset.
A permanent liability?
Yeah, a natural lawn in a desert climate is exactly that. It is a biological organism that will endlessly consume water, labor, and chemical resources until the day you physically remove it. Upgrading to a highly engineered synthetic solution stops that perpetual bleeding.
It totally stops it.
It pays for itself in a few years, and then it continues to actively deliver psychological and functional value for 2 decades. This raises an important question we should all be asking ourselves.
With that,
how critically are we evaluating the hidden, recurring costs of the things we just passively accept as natural or standard in our lives? Just because something is the traditional default option doesn't mean it isn't quietly draining your resources.
that is a phenomenal takeaway. We started this deep dive exploring the sheer absurdity of pouring 73,000 gallons of precious drinking water into the desert dirt just to keep up neighborhood appearances.
Yeah, it's wild when you look back at it.
And we journeyed all the way through the advanced material science of UV-resistant fiber optic-like polymers, the mechanics of draining monsoon floods, and the intense, heavy machinery combat required to conquer Nevada's native caliche rock.
It's really a testament to the incredible, sometimes extreme lengths humans will go to in order to adapt our immediate environment to fit our aesthetic expectations,
Yeah.
while simultaneously adapting those expectations to survive the brutal realities of our climate.
I genuinely want to commend you, our listener, for diving into a niche, highly specific topic like commercial artificial turf with us today. Because, as we've seen, we weren't just talking about fake grass. This entire topic serves as a brilliant lens into environmental adaptation, smart urban design, and rigorous long-term economic strategy.
It really proves that sometimes the most sophisticated, complex engineering in our cities is hiding in plain sight, right under our feet.
Exactly. I want to leave you with one final, slightly provocative thought to chew on as you go about your day. We've established that a highly engineered synthetic environment can save millions of gallons of water across a drought-stricken city.
Right.
It can completely eliminate the runoff of toxic petroleum fertilizers into the groundwater, and it can perfectly mimic the psychological benefits of nature in a climate that is actively hostile to biological life.
It forces a profound shift in how we define environmentalism.
It really does. So here's the question for you. At what point does the highly engineered, manufactured fake environment actually become drastically more ecologically responsible than stubbornly trying to force the natural one to exist? The next time you walk past a perfectly manicured, vibrant green corporate courtyard on a scorching 115-degree afternoon, take a second look at the ground. You might just be looking at the most environmentally responsible infrastructure in the entire neighborhood.